little sting thing. It's great. Hi everyone, and welcome to Saturday afternoon. This afternoon we've got a fellow who needs no introduction to a lot of you, Matt Trentini. Matt's been hosting the MicroPython meetup in Melbourne for several years now, and is a prolific contributor to the MicroPython ecosystem and culture. And he's here to talk to us about MicroPython, the best bits. Please make him very welcome.
Thanks, Nick. Thanks, everyone. First, housekeeping. If anyone wants stickers, we've got a bunch of them. They're really cool and cute, so I highly recommend grabbing a couple. Andrew's waving them about over his head, so go see him. And if you don't want to interrupt, come grab them afterwards, no problem. Slides are available on Discord and the Eureka channel, so if you want to play along at home, they're there. And really, I've changed the title without telling the Pycon folks. I just couldn't get through everything, so today's just some of the best bits of MicroPython. Don't tell anyone. So I'm Matt. Hi. I've got about 25 years experience, which I'm kind of proud to say that, but also, God, it feels old. And I've been lucky enough to play with most parts of the software stack, whether it's desktop software or embedded or cloud stuff. But a lot of my time in this domain has been working close or on the hardware. And about 10 or 15 years ago, I was getting a bit jaded with a lot of that embedded development because it was sort of stuck in its own little time capsule of building in C and quite slow developments when you look around at the rest of the software space and people are trying to progress with more agile developments, continuous integration, better tooling, all this kind of stuff. And embedded is kind of plodding along the way it had been for many years. And so I'd been looking for an improvement or a better way to do things in embedded. When MicroPython came along, I kind of jumped at it. And so I'm a contributor. I've added some code and documentation. As Nick said, I've hosted the Melbourne meetup for a long time, which Nick started, just for anyone that didn't get that inside note there. I've given a couple of talks at Pycon AUs in the past, although they're a little different to today. In the past, I've gone deep. Today, I'm sort of going broad, and I want to give you a bit of a glimpse into some of the tooling and the features, which is part of the reason why I think MicroPython's a good environment and worth your time. I also use MicroPython professionally. We build medical devices with MicroPython. So for those that think it's sort of a hobbyist system, I'm happy to have that argument with you after this talk. Most of this I've sort of already talked about. I was planning on doing some demos. I'm not. I just didn't have time. So it's mostly a talk, and I want to get you sort of interested in some of these topics. And I've given you links so you can go look at things if they pique your curiosity. And hands up, does everyone know what MicroPython is, at least vaguely? That it runs on microcontrollers and it's Python, right? If not, just hang on for the ride, you'll be fine. So starting from the core guts of MicroPython, the REPL is the first thing I want to talk about. It's a best bit. MicroPython gives you a live REPL, and for those that have used Python, you might be thinking, well, okay, we have a REPL. That's not that exciting. But having a REPL that runs on your embedded device is a complete game changer because it allows you to inspect the device. You're able to manipulate the pins or communicate to peripherals in a live sort of fashion. And back in the days before, with C and C++, this is typically like a compile, deploy, test. It didn't work, so you try that again and again and again. And so having that live communication to your device where you can introspect what's going on provides just exploration and investigation. You can really see what's happening. It's a really freeing way to develop. It also gives you tab completion, which is nice, although I really want to get 3.13's prompt into MicroPython. Time for another day. Next one, file system. So again, everyone's got a file system on their regular Python environment, but having a file system on an embedded device is actually really cool. It lets you store your code on the device and lets you store logs and sensor information and configuration files. So if you want to change the way your system behaves, just store a file on your device. It seems simple, but it's a really useful thing. Serial connection, so we're talking about the REPL. There's a number of different ways you can get to the REPL on the device. The most common way that is provided out of the box is over a serial connection. The other thing I just want to mention is that you also have file transfers over that serial connection too. MicroPython has a way of getting files on and off the device over that same connection. And a bit of an age test, I wonder how many people actually realise what it is. We are going to skip over this rabbit hole, but if anyone's got an interest in serial factoids, ask me about this later if we have time. It's kind of interesting. moving straight on to Mpremote. It's the official tool to use with MicroPython. Command line tool. It's supported and used by the MicroPython core team, half of which are here today. Thanks, folks. What Mpremote allows you to do is to make that REPL connection, lets you transfer files in a very easy, sort of natural kind of way. But it also lets you run files from your PC, allows you to execute snippets of Python, lets you reset, all these things here, set your clock on your device, put your device to sleep, all sorts of things that you want to do. But today I want to mention the mounting feature, which Mpremote mount is kind of magic, and it's a really interesting way to develop on an embedded device. Because what it does is it lets you mount a folder from your PC on your device. It's just like, as I've said here, it's just like having the PC as your hard drive for your device. And the nice thing about this is that you can develop in your regular, I use VS Code, right? We use our Git repositories. And so you just develop as you would normally, you would commit as you would. And when you're ready, you just mount that folder on your device and you test. And you edit your files and you test. And you edit your files and you test. And it's a really quick way to do turnarounds and to develop with your embedded system. It's a relatively new feature, had it for probably a year or so, but I want to spread that word because we've gotten a lot of use out of using this feature. It's great. MIP is to MicroPython as pip is to CPython, so it's our package manager for MicroPython. And the important thing here is that I like to say that MicroPython has small batteries included. It doesn't have the vast Python standard library that you would be used to. It has a much smaller constrained one because the devices we're operating on have small amounts of flash and resources, so we need to be careful about what we deploy. So a bunch of packages are also hosted on MicroPython lib, which is a separate repository, and you can install those after you've got your device up and running. And MIP lets you do that easily. You can also install third-party libraries from GitHub or GitLab, and it makes it easy to do that as well. So how do you do it? You do it with Mpremote, just MIP install package name. If you're used to pip, this should feel kind of familiar. And you can also do it straight from GitHub. If your device has MicroPython, like Anthony's Raspberry Pi Pico W, you can also use MIP on a connected device. So you establish a connection to your Wi-Fi, and yeah, MIP install the package, which kind of feels really futuristic, being able to install packages on a device with like 30K of RAM. Yeah, it's pretty cool. As a quick example, SHUTIL is not provided by default, so I try to use it. Doesn't exist. MIP, it's just, it's sudo make me a sandwich. And there it will work. Yay. Thanks for the little, appreciate it. The Unix port's an important tool that we have, and I know that Unix and Linux are different, but that's okay. Unix is like an umbrella term for the MicroPython that runs on x86. Super useful thing because it's the same interpreter, it's the same code that you're running on Unix. So if you get it running on the Unix port, you're usually pretty confident it's going to run in your device. So it's especially useful for doing unit tests. So you can run your unit tests on x86 on the Unix port, and you know it's going to behave very similarly to the device. It's very handy to be able to configure the memory because normally you've got oodles of memory on your PC, but the Unix port allows you to specify the maximum amount of memory so you can simulate more closely your embedded device. And although it's easy to build the Unix port, we also provide containers. So you can just Docker, you grab a Docker container of the Unix port. It's also super useful because the tag can specify the version, so you can check for regressions between different MicroPython versions. So yeah, I would encourage everyone to get familiar with Unix port. MPBuild, I don't think it's overstating it that it might be the best build tool ever created for any platform in any universe. I did write it recently, so I might be a little bit biased. It does have a cool logo though, right? So MicroPython can be a bit challenging to build because it uses, it works on a number of different microcontrollers and they all require their own tool chains and their own dependencies. And so MPBuild kind of simplifies a lot of that by building in containers and knowing which containers to use for the various devices that you're trying to build for. It also has tab completion, which is really nice because it knows the name of all of the boards that you might want to build. So how do you do it? And this is the shortest, most boring animated demo ever because it's just MPBuild and then the name of your board. If you don't have the container, it'll go grab it and it will just build and spit you out a firmware binary, and that's pretty nice. For those, I also use an alias to make it even shorter because I don't like typing. We're also just starting to add, everyone's used textual, or if you haven't, go check out textual, a library by Will McGugan. It lets you do sort of GUIs in the CLI, and this is an example of what we're doing here with the ports and the boards there on the left, and that big stripy section in the middle, or on the right, is going to be where you can choose to build, or it'll give you information about your board, and so on and so forth. So stay tuned, I'll hopefully talk about that another time. The memory profile, just like Big Python, and yes, we call it Big Python, MicroPython uses a GC to manage memory. But because these devices have quite limited amounts of memory, you really need to be on top of this and make sure that you're not using too much memory and not fragmenting it in particular. And so MicroPython gives you a tool, meminfo, that will specify how memory is being used at any given time. It will spit out a whole ASCII line that will show you for each character how that block's been allocated. And so we've built a tool in-house, and thanks to my employer, PI, for helping release this. We collect meminfo data, and we also collect log information, and we produce an animation so you can see the logs and the memory information over time. And it makes it easy to identify from the logs what's allocating memory, and then you can go back and target that and use techniques to reduce that memory use. We need this for when you're trying to run devices for long periods of time in particular. So let's just have a quick look at what that animation looks like. Where's the pause button? So just to explain what's going on the left, we've got the logs coming out. On the right, that's the dump that you get from meminfo. I won't go into detail, but each of these characters here, you can ascertain how that memory is being allocated. And I've just got an async task here that's allocating memory quite frequently. And then periodically, I'm deallocating half of the memory. So we expect to see the memory grow, but you'll see the lines sort of increase, and then boom, get returned back to the heap. And so this allows us to see when we've got memory problems, because what you don't want is to see that continuously grow when you're running your application for days at a time. This helps build reliable applications. So that tool is available. We'd love to extend it a little further at the moment. Like the meminfo, it looks ASCII and nerdy, so we could actually have like a pictorial version, like have pixels for representing the blocks. There's a lot of room for improvement there, I think, but it's still right now, it was a really useful tool for us. Other useful tools. Everyone wants to play in the browser these days, so you can do that if you want to with MicroPython. Viper IDE is an IDE that runs totally in the browser in any Chrome-based browser, because it relies on WebUSB, Web Serial to make connections to your device. It allows serial BLE and Wi-Fi connections, has the file editor, file manager you can see there on the side. It has MIP integration, so you can install packages. It has a terminal built in. So it has all of the things you'd sort of want and need. Really good way to get started with MicroPython. I personally prefer VS Code and Mpremote because it gives you a little bit of extra power. But particularly if you're in the educational sector or if you're sort of dabbling with MicroPython, it's a really great tool to use. Yeah. And speaking of browser tools, for those that haven't used Wokwi, it's a browser-based simulator, so it actually simulates a bunch of hardware. Again, free to use. It has a large range of peripherals. So you can see here we've got an ESP32 connected to an LED ring, but you could easily put temperature sensors in there, or whatever sort of stuff you've got. They've got quite a large list of things that you can connect up and wire in the way you would on your actual hardware. And then you can run your software, and it will actually run and see if you can see if it works, which is quite nice. It also is available as a VS Code extension as well, which is quite neat. I just want to make a note there that it's quite a rich simulation. Like it even has the ability to reach out of the browser. So like this ESP32 has Wi-Fi, and this particular example is actually looking at a MQTT server that's in the cloud, which you can send an MQTT message to and set the color of those LEDs. And this all happens in the browser. It's pretty awesome. I'm trying to get the two developers to talk to integrate Viper IDE and Wokwi, because it'd be cool to have those extra features in the browser, but stay tuned. Miscellaneous async AO, I had to mention this because it's just a fundamental part of Python, but also MicroPython. It's so useful in the embedded space because a lot of the time we're dealing with micros that just have a single core. And also a lot of the operations that we do are sort of asynchronous in nature. We do something, we're waiting for a result, and we're doing something else and waiting for a result. So Asyncio is a really good fit for the embedded space, and it's a foundational library. A lot of other libraries are built on it, like AIO REPL, which is a library that you can use to provide async features to the REPL. And this has been a real win for us. If you've got an async capable application, you can run it from your REPL, so it's running live. But instead of being blocked until the application finishes, you can still interact with that running application. So we can do things like have control loops, and they might be generating a PID loop to keep a heater at a certain temperature, right? But while that's running, we can actually inquire as to how it's performing and even change the values to modify it on the fly. So it's really, again, we've got a really tight sort of feedback loop and a really quick way to iterate with our applications. We also used it for we had a state machine, and the state machine was getting quite complex, and we want to test what happens when it gets into unusual states. And you can just inject the states from the REPL. It's a really useful thing to have. Anthony, this would also allow you to download your files while your application's running too. AIO just a quick mention, but if anyone's used BLE and they've tried to get it working on an embedded device, I'm sure they would have shared my pain doing that. It's a really quite a complex beast, and it's often callback heavy, so you get a lot of interrupts coming back, a lot of callbacks, and you need to figure out what's going on as these callbacks are being generated. AIO simplifies a lot of that by introducing async functions to a BLE library. So you can do things like await a connection, and you don't have to wait for the callbacks. You don't have to inquire as to what message has been generated. The next line just means that you've made that connection, and so then you can do the next step. So you kind of end up with quite a linear, easy to read chunk of code with a lot less code rather than having all these callbacks being generated. So for me, this has been the best way to do BLE development on any platform, library, language. It's been great. So how are we doing for time? So C user modules. I've got the warning down the bottom there, only to indicate that we're actually delving into the C world here, because one of the superpowers of MicroPython is that it's written in C, and also makes it very easy to create C modules. So why you'd want to do that is for two obvious reasons. You want to integrate a C library because there's lots of them out there. But the second one is if you want to optimize your code. So you can, if your profiler shows you, of course, you should check your profiler. If your profiler shows you you've got a bit of code that needs to run faster, you've always got the option to drop into C and create a small chunk of your code in C that's accessible from MicroPython. And that's actually relatively easy to do. And the disadvantage here is that you do need to produce your own firmware. So we don't have that rapid iteration cycle that we like with MicroPython, but you do get C level of performance, right? So for me, this is really nice in the sense that I never have to be worried or scared that MicroPython's, I'm going to run out of performance, right? I know that I can always drop into C and write small chunks of my system in C and then execute them from MicroPython. And so that way I'm sort of doing surgical cuts, like wherever there's a little bit of code that needs to be improved, write that in C if I really have to, and then just get the benefits of developing in MicroPython for the vast majority of my code. And related to that, I have to talk about native modules. This is another best bit. Native modules is similar to the C user modules. We can compile chunks of native code, and we can package them much like you would a DLL or a shared library. And they've got different pros and cons here. Similar to performance to C, so we're still talking fast performance. They can be loaded at runtime, which is awesome. We don't need to build our own firmware still. But the little module has to be built for the platform that you're targeting. So if you want to support a general library, you have to build it for each of the platforms that are available. And there's a few other technical constraints, but we can leave those around for this particular doc. It's also worth mentioning there's been a development of combining WASM and MPy in an unholy sort of mix. You can sort of package any library that emits WASM, theoretically, and these ones have been tested. And so you can compile these and emit WASM, and then take those and compile them down to C, and then automatically compile that C into a native module. And so you get near native performance running in MicroPython in a module that can be loaded at runtime. And I think it's a really exciting development. It's active right now. Thank you. LVGL is a really popular embedded UI toolkit, and this is kind of a bit of work that we're doing at the moment as part of my day job. And the core LVGL team, they maintain MicroPython bindings where they parse their headers, which generate all these widgets, and they give you MicroPython bindings for them. And the performance is identical because you're calling through to the C code. But it's easier to write because it's MicroPython, and the UI can be modified at runtime, which you're not going to do in C. And it's really helpful. The part that's been missing until recently is packaging this system, right? The LVGL core team provides those bindings, but they don't provide a firmware binary for the device you need. So we're working hard to try to fix that. And we're going to do things like package LVGL as a C user module and package drivers as a native module. That's the goal we're trying to get to. We also use Asyncio and AO REPL here. So this is a convergence of some of these cool features. Asyncio allows us to sort of tickle the event loop in LVGL, and AO REPL means that we can interact with the application while it's running. Yep, so that's right. So I've got 20 seconds. This is Andrew, who's, put your hand up, Andrew, it's great. This is a work, you can see here that he's introspecting what is going on and moving that label around. But then something that's just a bit difficult to do in C is just blobbing in, say, 12 lines of text, and now you can move that label around. And that feature wasn't there when we built it. So you can imagine being on a call with a customer and they want to go, oh, what happens if we move X widget over here? And we can just do that on the fly. Really helpful. Go to the next. I think, not you. Give me a sec. Okay, honourable mentions. As I said, there was too much to discuss, so just one-liners. If these things are interesting to you, go look them up. We've got links. PyScript, I could give you a whole talk on PyScript, but it's basically MicroPython or CPython in the browser. If that's exciting to you, and it should be, go check it out. Belay is a tool that allows you to put your code on a MicroPython device from a Python application on your PC. So in your PC Python application, you can decorate it with a header, with a decorator, and make that run on a device that's connected. Kind of cool. Mpremote allows you, like Mpremote, to run code on your device, but it actually synchronizes files. It doesn't actually just mount the device, it actually synchronizes the files on both devices and the PC. MicroPython PyTest is an effort to get PyTest running on MicroPython. We've got unit tests running, but PyTest was just too giant to pull across easily. So based on a talk given at last year's Pycon AU, MicroPython PyTest came into being. We've got Viper and native emitters, which are built-in features of MicroPython, where you can add decorators to your code and it goes vroom. I'll leave it at that. There's some technical information there you'll need to go learn. Hardware in the loop testing, important thing in the embedded space. You want to test your software running on your hardware devices. That can be quite complex and difficult to do. Because we've got a serial communications to our device, it actually makes it a lot easier. And Hans is here somewhere. Hans is trying to get this to work with the Octoprobe project, where he's built a generic device that we can host a device under test on and put new firmware on it and do all our tests on it. PDB support, we're trying to get PDB running on MicroPython. It's not there yet, but it's getting pretty close. USB device, we want to, if you want to get a USB device as a client running on MicroPython, there's no better solution than this. It allows you to specify your descriptors at runtime and instantiate a USB device. I might skip over this, but there's too much to talk about there because I'm running out of time. My conclusion is that MicroPython's still a teenager, right? It's 11 years old, but it's already pretty great, and we've got some years now of experience using this professionally, and it's working out pretty well. I think it's a great environment right now, but it's also really exciting to see where it's going and how quickly it's developing. So that's really cool for me. And just one more best bit, especially for the people in this conference, is that MicroPython is Python, right? So we get all the benefits of knowing Python and using it on these little devices. So for me, that's really one of the best bits. I think that's all I've got for you. Thanks.
Thank you, Matt. We've got 5 minutes for questions. Luxury.
Yeah.
Put your hand up if you've got a question. I'm going to start.
By the way, we've got like a good chunk of MicroPythonistas here, so if we can't get an answer, there's something really wrong. Yeah.
You were talking about being able to test on proper x86 platforms.
Yep.
What about peripheral testing? So if you've got devices that are esoteric, I2C or whatever, how
Yeah.
do you go about testing those?
You've got two options, and the one we most use is to mock them out.
Yeah.
Yep. And so we usually mock them out sort of at the communications layer, whether it's I2C or SPI. So we know what I2C is doing, we know what SPI is doing. But the other option is that you can actually get it running on Unix as well. And it's a bit harder and it's a bit more cutting edge, but you can actually get these things running on your x86 device.
Nice.
Yeah, so I was just wondering about for the memory management stuff, because it's like you have so little space, and with the fragmentation and everything, are there just patterns that people are doing in MicroPython to avoid things, or is it kind of that like usually you actually don't, you're kind of not worrying about memory that much in practice because of what you're doing?
Well, that's the thing. So Python gives you lots of tools to do programming tasks really rapidly, right? But that usually means you don't care about memory allocations. You just care about getting the job done. But particularly with MicroPython, but also with Python, you can do things like pre-allocate your byte arrays and reuse them, for example. So a really common one is we want to send data to a device over a communications channel. And the obvious way to do that is to generate a blob of data and send it across. But that allocates a temporary every time. So MicroPython provides ways of allocating a byte array once and reusing it and then passing it in through the methods, so you don't have those.
Provide the buffer, for example.
That's right. Yeah. Yep.
Awesome. More people up the front. Come on, people down the back. You've got to. I know it's afternoon, but you know.
I think it's kind of quite a similar question, and maybe it might have been over the top of it. But what sort of guarantees or understandings that you can have while you're using MicroPython to say know that this is using statically using memory as opposed to just underlying dynamically creating using it all?
Yeah, it's kind of a learning process, and part of it is that Python isn't that transparent about how you manage memory, and it's a pro and a con, right? They can see you have to be very aware of what you're doing with the memory, and that means that you're very aware of what that memory is doing. So in Python, you tend to learn by using tools like the memory profiler as to how and when temporaries get created. But it is a learning process, and that is kind of a detail that you need to worry about. But I guess I'd encourage people just to not care about that at first. Just get your application done and working, and then analyze it later and figure out where you need to make the improvements. Yeah.
You're all so close together.
At the risk of debugging my own project,
We offer a consultancy service if that's
what ideas do you have for looking at debugging or working out why something fails after a time? Are there sort of good logging patterns and practices or debuggers? What sort of tooling is out there?
Yeah, so we can hook into the standard Python logging system, so that for the most part you've got very similar features to regular logging in Python. That's the first port of call. Other things kind of depends on the specifics. Like you might want to keep your REPL open so that you can get debug information when problems occur. That's actually really useful to introspect what the variables are doing. But yeah. Perhaps talk to me afterwards and we'll see if we can fix your problem. Yeah.
All right, we've got time for one more question, I think.
Yeah, cool.
How do the real-time capabilities compare to a bare metal C or an RTOS application?
Yeah, it's not a real-time operating system is the short answer. The best thing you can do is drop into C and use whatever guarantees your microcontroller manufacturer gives you on their API. That'd be if you're looking for tight real-time operating system stuff, probably not the right tool for the job. But I would say that a lot of the C real-time operating systems aren't that real-time as well. So, yeah. Yeah. So MicroPython gives you access to regular ISRs and to interrupts, so that part of the system actually performs very well. as with anything, where timing is critical. Measure. Like, make sure you're doing it within your timing constraints. Yeah.
All right, please join with me in thanking Matt Trentini again.
Thanks, everyone.